Hello friends, today we'll get to know about the grooving operation. Okay, a controller will be Fanuc as usual, and this is the profile of grooving operation. The measure dia is 50, and you have to maintain a groove of 40 diameter, okay, of length this much, 10 mm. Okay, there are few things you need to know about grooving operation. First, talk about the insert of groove. Okay, let's say this is the insert of groove. Okay, its width will be 3 mm. Okay, its width will be 3 mm. Okay, so while do offsetting, what happens? This face of the insert, okay, we touch on this face of the workpiece like this. Clear? So what happens? This face of insert gets offsetted, okay, and it goes and while offsetting, the value goes to the machine. Clear? And this face becomes 0. Okay, so while moving the insert from origin to this point, okay, to origin to this, let's say point number 1, and this is point number 2. Okay, so from origin to this point number 1, we have to add the value of width of that insert, which is 3 mm. Okay, and it will become like this. Clear? If you forget to add the value of width, then the grooving operation will start from here. Okay, this one means this amount of metal will be removed. Okay, the hatching part. Clear? So don't forget to add the width of that insert while moving from origin to point number 1. Clear? So let's write the program for grooving operation. So go 1, 2, 3, 4 is your program number. Then, like always, it's T0000, then G00X0, G00Z0, then T0404. Clear? Then comes G97, S400, M4. G97 is your constant spindle speed. Okay. Then comes the safety, G00, Z2.0, G00, X will be raw metal dia plus 2 mm. Okay, 52.0. It's not necessary to always take 2 mm. You can take whatever you want as per your convenience. Okay. Then comes M7, which is coolant down. Okay, so G code for grooving is G75. Clear? Before that, we have to write a line for this distance. Origin to this means origin to point number 1. Okay, so it's a linear movement. Then it goes like this: G01, Z minus 15. No. If you write minus 15 over here, then you will remove this amount of metal, which will lead to rejection of your job. So kindly add this length plus 3 mm width. Okay, the 15 plus 3 will become 18 minus 18.0. Let's take the feed 1.0. Okay, clear? Then the G code for grooving operation is G75. G75 0.1. G75 X is 2.0. Z is how much? 25 minus 25.0. P200 Q 2500. F 0.08. Okay, F is 0.08. Then add the safety line. G01 first goes safety in X direction, X 52.0. Then goes rapidly G00, Z2.0. Then again G97, T0000. Spindle off, coolant off. Then moving G00, X0, G00, Z0. Then the value, then it is M30. Programming and design. Okay. So let's talk about few terms like this, and this. Okay. So R is your retraction. Okay. R is your retraction. X is the depth in x-axis. Depth in x-axis. You want to dig. You want to dig or remove. Clear? Then comes Z. Z is the length of your what? Groove in Z direction. Length of groove in Z direction. Okay. Then comes P. P is your incremental depth in x-axis. Incremental depth in x-axis, which is in micron. This is 200 micron. Okay. Then Q is your incremental depth in z-axis, which is also in micron. 2500 micron. Then F, like the letter, is its speed. Clear? So this is all about the grooving operation. Okay. It starts from here and here. So this is the syntax. One need to remember this thing. Okay. So yeah, this is the end.